Alright, Chapter 2, Linear Equations and Functions. 2.1 Function and their graphs. Goal, identifying graph functions. A relationship is a mapping and repairing input values, output values. A set of input values are the domain, and the set of output values is the range. A relationship is a function. Each input has exactly one output. A relationship is not a function if any input has more than one output. Relation functions may be represented in mapping diagrams, tables, ordered pairs, graphs, and equations, and verbal descriptions. Vertical line test. You can tell whether a relation is a function is in the graph coordinate applying the vertical line test. Vertical line test of function. A relationship is a function if and only if no vertical line intersects the graph of the relationship more than one point. So if it only has one vertical point and not a function. So a relationship is a function only if no vertical line intersects the graph of the front relation at more than one point. The input variable is an equation with an independent variable. The output variable is a dependent variable. In y equals 2x minus 5, x is the independent variable, and y is the dependent variable. The graph of an equation of the two variables the graph of an equation of the two variables is all points x and y whose coordinates are solutions of the equation. Graph an equation to variables. Step 1, make a table of the values, write the ordered pairs. Step 2, plot enough solutions to recognize a pattern. Step 3, connect the pattern points in a line or a curve. Two, linear functions, function notation. Goal, identify, evaluate, graph linear functions. In example 4, we write a linear function to model over the cost of a fitness club membership. The function of a form of the form is y equals mx plus b, where m and b are constants, such as y equals 2x plus 1 is a linear function. Graph of a linear function is a line. That means the graph of a linear function is a line. By the name function, the Greek letter f, you can rewrite the function notation. So now we have the function notation is of x is equal to mx plus b. The function notation is mx reads as value of x, or simplified f or of x is equal to the function notation mx plus b, where m and b are the constants. Note the function notation is used to place in the place of y. For the domains of the function x consist all of the values of x which are in the function is defined. The range consists of all ranges of fx where the x is the function domain of f. A function does not have to be named by the letter f. You can use all other letters such as gh as following examples. Graphing linear equations. You graph the first, making the two tables graph linear equations. You need only 2 points graph of the linear equation. So you would probably solve x for 0 and or maybe y for 1. And you'd have a range x and a y value. You'd need 2 points. Reasonable domains. In a real-world situation, a function model may not make sense of all of the mathematical possible values. Independent variable, for example, the function relating to the circumference of the circle to a radius makes sense only for a positive radius values. In case, you can restrict the domain of the model. Two, 3, slope and the rate of change. Find the use of slope of a line. Slope is over the non-vertical line ratio of a linear vertical change. Rise to its horizontal change and run. Slope is given vertical change of rise into its horizontal change of run. Slope is given the measured steepness. To find the slope, the skateboarder ramp shows the ratio of the ramp rises to run. Slope is equal to rise over run, or 3 over 7, 3 foot rise, run a 7 foot. Just 2 points determine the line. 2 points are needed to find the slope. The slope of the line is the same regardless of whether the 2 points of the line are used to find the slope. The slope of the line is m. The slope m is non-vertical line passing through points x1, y1, and x2, y2 is given in the formula below. Slope is equal to y2 minus y1 over x2 minus x1 equals rise over run. Positive and negative slopes. If the graph line falls left to the right and the line slope is negative, the relationship is the true general of the following details relationship between the slope of the line. So on the classifying lines of slope, we have a positive slope, and when the slope is greater than 0, we have a positive slope. Line rises from left to right. The negative slope, the slope is less than 0, and line falls from left to right. Vertical, 0 slope, the m is 0, and we have a horizontal line. Undefined slope is used as the line is vertical, the function is a vertical. Do 4 quick graph linear equations. Goal: use slope-intercept form and standard form to graph equations. You saw that the graph ym plus mxb, the slope is m, and the intersect of y-axis would be x is equal to 0, so it gives you b at the intersect of y. Y-coordinate of the point where a graph intersects y is the y-intercept. So the graph y equals mxb has a y-intercept, and a y-intercept is b. A linear equation where y equals mx plus b is slope-interception form. M is the slope, b is the y-intercept. Y equals mx plus b. Graph the equation in slope-intercept form. Step 1, write the equation in slope-intercept form for y. Find the y-intercept corresponding point. 3, find the slope using it as the second point of the line. 4, draw the line through the 2 points. Standard form. An example, we found y-intercept. X-intercept is the x-coordinate of the point where the graph intersects x-axis. Equation can be written in standard form. Ax plus by equals c, where a and b are both not 0. Using standard form linear equation, you can easily find that x and y intercept by drawing a graph. Write the equation in standard form. Find the x-intercept letting y equal 0 and solving for x for the plot corresponding point. Step 3, find the y-intercept by letting x equal 0, solving the y for the plotting corresponding point, draw a line through the 2 points. Parallel and perpendicular. 2 lines are parallel if they lie in the same plane, never intersect. 2 lines are perpendicular if they intersect to form a right angle. You can use the slope to determine whether the 2 different non-vertical parallel perpendicular. Consider slope and parallel perpendicular lines. Consider 2 differential non-vertical lines, line 1 and line 2, with the slopes m1 and m2. Lines are parallel if and only if they have the same slope m1 equals m2. Lines are perpendicular if and only if the slopes are negative reciprocals of each other, so m1 equals negative 1 over m squared, or m times m2 equals negative 1. Two 5, writing equations of lines. If you know the slope of the y-intercept of a line, you can rewrite the equation using slope-intercept form. Know that slope and any point of the line, you can write the equation as point-slope form. Writing equations of a line. Slope-intercept form gives the slope as m and the y-intercept b. The slope-intercept is y equals mx plus b. The point-slope form, giving a slope of m and a point x and y. Using the point-slope form, y is equal to y minus y1 equals m times x minus x1. Two 6, direct variation. 2 variables x and y show the direct variation vary directly. If y equals x y equals k times x, k is not zero constant called the constant variation. The direct variation equation y equals x, the constant variation times x. So s equals 2t. The direct variation equation is the constant of x variation k is equal to 2. The graph of y equals your constant variation, y equals constant variation times x is the line, slope is x. Also, y-intercept is 0, so the graph of the directive equation passes through the origin. Identify the direct variation. You can rewrite y equals m at x, direct variation, y equals k times x, or y over x equals k. So instead of the data pairs, you should direct variation ratio to y to x. Two 7, developing concepts fitting a line. Question, think about it. Scattered plots. Alright, set a correlation in scatter plots, find the best line. Scatter plot is a graph of a set of data pairs x and y. Scatter plot can help you identify the type of relationship correlation between two variables. Positive correlation, as x increases, y tends to increase. Negative correlation, x increases, y tends to decrease. Relative to no correlation, there's no absolute obvious pattern between x and y. Lines to fit. If the points of the scatter plot appear to lie closely on some line with a positive and negative slope, but the correlation is strong, you can reasonably model the data of the line. The line must closely model the data called the best fitting line. You can approximate the best fitting line by graphing. Step 1, draw the scatter plot of the data. Step 2, sketch a line that follows the trend of the data. The line should be close to as many points as possible. They should be as many points above the line and below it. Two of the 2 points appear on the line on the line. Estimate the coordinates of each of the point. These points do not have to be original data points. Step 4, write the equation of the line passes through the 2 points. Step 3, equation gives a model of the data. Alright, Chapter 2, Summary with a review, relation to the domain, range, function, equations, 2 variables, independent variable, dependent variable, linear function, functional notation, slope, y-intercept, slope-intercept form, x-intercept, standard form, a linear equation, points, slope in the form, direct variation, constant variation, slope, point, positive correlation, negative correlation related to the best fitting line. 2.1 was functions of the graphs for their graphs. 2.2 linear functions, function notation. Step 3, 2.3 slope and rate change. 2.4 quick graph linear equations. 2.5 writing equations of the line. 2.6 direct variation. 2.7 scattered plots and correlation. Chapter 2 test. Chapter 3 linear systems linear equation.